We have parametric equations that are describing the movement of a particle in the xy plane with respect to time. And we're asked, first of all, so I suppose, yeah, we've got it's like moving around, somehow. But we're asked to show or explain why the path of the particle never actually crosses the x-axis. All right, so actually it's just going to stay potentially one side. And to do that, we need to look at y equals 0. So to cross x-axis, require y equals 0. But y is equal to 2e to the minus 3t, and this is actually going to be greater than 0 for all values of t. I could draw a little exponential. This is a negative exponential, so it's going to, well, I suppose t is greater or equal to 0. So you do get this little bit, and then you get this bit coming down like that. But it never, there's an asymptote at y equals 0, but it never actually touches. So particle will never cross. I'm happy with that. Determine the exact values of t when the path of the particle intersects the y-axis. So that's going to be when x is equal to 0. So I'm going to get e to the 2t minus 4e to the t plus 3 equaling 0. And this is actually a hidden quadratic. Okay, you've got to realize like there's a e to the 2t and an e to the t, so it's either going to be like really complicated or not that complicated. And it's actually, we can just write it as e to the t squared. You only have to add a few more terms. Like if you added like a sine t, this would actually not be solvable exactly. But this is a very particular form. That's what I'm trying to say. Okay, and so you can either do a substitution, u equals e to the t, and then we'll get u squared minus 4u plus 3 equals 0, or you could factorize directly in terms of e to the t, which I'm going to do here. So I'm going to get minus 3 and minus 1. That will work out. So then t is going to equal ln 1, which is 0. But let me write it down, ln 1 or ln 3. That doesn't say, oh, it says exact. Sorry, yeah, so 0 or ln 3. Nice. Right, let's move on to C. We're asked to show that dy by dx is equal to this. Parametric equations, differentiation involves a chain rule. So dy by dx is going to equal dy by dt times dt by dx. And then dt by dx is 1 over dx by dt. So we can write it like this. So dy by dt is simply going to equal minus 6e to the minus 3t. I'm just using the chain rule. I'm multiplying the, like differentiating the outside, which is e to the something, like I have a main e to the something, and I times by the derivative of the inside, which is the minus 3t, so times by minus 3. Or you could just use the result for e to the kt, which, whichever, which is an application of the chain rule anyway. So I get minus 6e to the minus 3t here. Right, dx by dt. That's going to be similar lines 2e to the 2t minus 4e to the t. Now note, we're asked to leave our answer in this particular form, so without anything, so a 3 on the top. Well, I think first of all, I'm going to multiply through. I'm going to show my working clearly here because it's a show that question. I can actually factorize out a 2 at the bottom. And then I'm going to times by e to the 3t divided by e to the 3t. Because then I'm just timesing by 1 essentially, but now these will cancel. The 2 will also cancel partially with the 6. So I'm left with minus 3 over e to the 5t minus 2e to the 4t. And I'm nearly there, it's just that it's the other way around here, so I just need to sort out the negative. And I think it's fine to just write it straight down. So I'm timesing the top by minus 1, the bottom by minus 1. Okay, just show enough work in so you don't just, write the answer straight down. You need to show where your answer's coming from, and I think that is enough. Right, finally, part D says, hence find the coordinates of the particle when its path is parallel to the y-axis. You remember, we've got this plane. We know it doesn't cross the x-axis. When is it moving parallel to the y-axis, like in this direction here or this direction here? Okay. Well, it's going to be when the gradient of this function, so this would be a gradient of 0. It's going to be when the gradient's actually not defined. Uh, or more specifically, it's actually when the denominator is equal to 0. Because it will be defined for all other values. All right. Now here I'm going to rearrange it to 2e to the 4t equals e to the 5t. Now remember, these exponentials can never equal 0, so I can just divide by them with no problem. Like when you divide by sine x, you have to think about whether sine x could be 0. But here I can just get 2 equals e to the t, because I'm dividing by e to the 4t and then just using my rule of indices, subtracting the 4t from the 5t, which means that t is going to be ln 2. I'm going to leave it exact. Now, for the moment, now we're asked to work out the coordinates themselves, so I'm going to return to these x and y equations. And substitute my value of t in. All right, and this can actually be really nicely done without a calculator. I think you can, I'll check in a second, you can probably just substitute it in, but it's going to be e to the 2 ln t, which actually is e to the ln 4, minus 4e to the ln 2 plus 3. And this simply, e to the power of ln, they just cancel out. So we're left with 4 minus, and then this just cancels out. So I've got 4 times 2. So 4 minus 8 plus 3, which is going to give me minus 1. Now you might say, look, I don't do that. I just want to stick it in my calculator. Let's just check. So we get that. And then it's going to be e to the 2. This is going to work, isn't it? But it's quite nice to see it without. Okay, so we also get minus 1. So at least you can do that to check. It doesn't say you have to show detailed reasoning, so I think it's enough. But anyway, that's how you do it without. And then y is going to be 2e to the, well, it's going to be ln 2 to the minus 3, which is actually 2e to the ln of 1 over 8. These bits cancel, we're left with a quarter. The coordinate is going to be -1 and a quarter. Well done.